In this sequence of videos, we've been doing some problems about correlation and regression from our textbook, Mario Triola's Elementary Statistics in its 14th edition. I have one more problem I'd like to do, and this one might be my favorite of the ones we've been talking about in these videos. Crickets and temperature. Find the best predicted temperature at a time when a cricket chirps 3,000 times in 1 minute. And then a further question after that, what's wrong with this predicted temperature? So apparently we're going to have to do some critical thinking at the very end of it. But the basis of the problem is I have paired data. I have chirps per 1 minute. Those are going to be my x's. And then I have temperatures in degrees Fahrenheit, and those are going to be my y's. I'm asked to make a prediction in the end for a temperature at a time when there are 3,000 chirps in 1 minute. If you actually just look at the data, you might already be able to see a little bit about what's going to be wrong. But the question's about a prediction, so we need to make that prediction. I'm going to start by entering the data into my calculator. So I'm going to go into my list here. I'm going to use list 3 and list 4. I'm going to pretend I have some data in L1 and L2 I actually want. And that way we've at least used L3 and L4 at least once in these videos. So I'm going to enter the chirps in for my L3s. That's where my X's are going to go. All right, I'm going to enter my y's into L4. And finally 79.6. All right, and I should scroll through the data and make sure I haven't made any mistakes at the data entry level. Having checked the data, let's go on and calculate that R value. This time I do need to tell the calculator my data is in L3 and L4. So L3, L4 here, and I can press enter. And I get an R value that's pretty high. 0.874. Well, that's bigger than either of these values, so at either significance level, there is a significant linear correlation. So there's a significant linear relationship in the data. I will get to use the regression equation. So 27.628 plus 0.052x. All right, I'm asked to make a prediction. 3,000 chirps goes in for x, and a temperature is supposed to come out for y. All right, so let's see what happens. 27.628 plus 0.052 times 3,000. And I get something that's really close to 184 degrees Fahrenheit. So if I was just doing this naively, I would say at 184 degrees Fahrenheit, I would expect 3,000 chirps per minute. And then I remember that I was supposed to figure out what was wrong with this. And I look at that 184 degrees Fahrenheit and I think, wow, that's very hot. I don't think that's what the outside temperature is going to be, especially if I look at the rest of the temperature data, right? It's nothing like the rest of these temperatures. And what's really going on is we were asked to make a prediction for 3,000 chirps. And when I look at the amount of chirps in this table, none of them are even close to 3,000. The highest is 1,200, which is, just more than 2 times. 3,000 is more than 2 times that value. And so what we're doing here is we're extrapolating. We're using a data value that's so far away from the rest of the data that this wouldn't make any sense. And would probably kill the crickets anyway. So what's wrong with this predicted temperature? Well, it makes no sense. It's way too hot, and it's way too hot probably because we're using a data value that's too far from the x values in the table. We're extrapolating.